All of our math is based upon a two-dimensional projection. What they do in calculus, they will reduce the action of all things. They'll keep trying to reduce it down to one moment because they believe Newton's first law that everything moves in a straight line, or everything is still until acted upon. They forget that everything is in motion, and that concert of motion is a necessity. They have to include all the other forces involved in order to have equanimity in their equations.
And so how, in a practical sense, does this affect mathematics?
Well, once we let go of Cartesian space and the 90-degree angles, well, picture this. Let's take another practical place. Look at a computer chip. It has all of these 90-degree turns on it, typically, where they run the electricity. Can you imagine running at 186,624 miles a second in one direction, and you hit a wall, and you've got to stop, bounce off of that wall, and then you pick up your speed and you bounce off the next wall, and you bounce off the next and next and the next and the next. How much heat are you building up? How much friction is being built up from the interference in comparison to if it was just spherical, just going around? It would build up no heat. And if you allow it to be spiral, which my patent was talking about, that first patent was talking about, you're able to utilize all that energy so you don't need the cooling systems. You don't need all of this loss or entropy. None of that occurs when you go by universal standards. That's all they have to do is follow what the universe does. We have the contractive side, patented, ready and available.